Well, hello everyone and good morning. Welcome to today's educational webinar on multi-year modeling in HOMER Pro and HOMER Grid. How can it help you? When can you use it? I'm Marilyn Walker, the Chief Operating Officer here at HOMER Energy, and I'm excited to be with you here today. Really appreciate all of you showing up. We offer these free educational webinars monthly so that we keep you up to date on what's happening in the world of HOMER and how to best use the HOMER software, our services around the software, and sometimes also our close partners who offer products and services that we think offer value to you. Today's main webinar presenter is our Chief Executive Officer, Dr. Peter Lilienthal, the original creator of the HOMER software. Steffi Clauter, our product manager, is also here on the line to assist us with questions, and she's going to take the Q&A section today. So for those of you new to HOMER, the name is an acronym for Hybrid Optimization of Multiple Energy Resources. The HOMER approach includes three different processes nested together. At its core, HOMER has a simulation engine. It simulates the operation of an electric power system for 1 year, hour by hour or minute by minute, and then at each time step, HOMER looks for the most cost-effective way to meet the electric load based on the set of constraints that the user defines. Simulation tells you how one system operates, and the optimization step then simulates hundreds of different systems to find the least cost system. HOMER also has an option to do sensitivity analyses, which allow you to look at the impact changes in variables that you don't have control over, such as fuel price or wind speed, have on your system design and costs. And just while we're on this slide, if you go back to that blue egg there in the middle, we're talking about running the system for 1 year. The multi-year option that we're going to be talking about today actually lets you model the system for 25 years explicitly through the entire life of the project. So using HOMER, either HOMER Pro or HOMER Grid, to design and optimize your microgrid or distributed hybrid energy system has three main steps. First, you provide information on the economics, such as the interest rate, your energy demand profiles, your location. That's going to help us get your renewable resources for you, solar radiation, wind speed, and the types of equipments to consider, which are shown here as the system components. HOMER then steps through the three nested processes I talked about in the last slide: simulation, optimization, and optionally sensitivity. And then it provides detailed results not only on the economics of the system, but also on exactly what's going on, literally in every hour, if that's what you need to know. So I mentioned earlier, we now have two versions of HOMER. HOMER Pro is our original product and it's our flagship. Broad applications for microgrids in many markets. HOMER Grid was released not quite 1 year ago, designed explicitly for behind-the-meter systems in grid-connected markets where demand charge reduction, time of use rates, maximizing self-consumption, incentives, resiliency, or some combination of these are what matters most. A key piece to making HOMER Grid useful is having the right, sorry, I messed up. Anyway, so today we're actually going to talk about the release of HOMER Grid 1.4 and multi-year is part of that. So just before we hear from Peter, I want to explain the multi-year, how this multi-year capability is presented in each product. The ability to explicitly model year by year rather than just 1 year, which was the original HOMER standard, was just introduced in HOMER Grid 1.4 this week. And Peter's also going to show you the other new features in this release. In HOMER Pro, multi-year is one of 9 optional modules that you can add to the base product. So if you have a HOMER Pro license and you don't see the multi-year functionality, please contact our help desk about or your sales rep about getting that added to your HOMER Pro license. Okay, so now I'm going to turn it over to Peter, who's going to show you how to model in HOMER Grid and HOMER Pro using the multi-year option.
Thank you, Marilyn, and thank you all for attending. And as Marilyn said, we're going to talk about what's new. HOMER Grid 1.4 was just released this past Monday, the 15th, and HOMER Pro version 3.13 is going to be released in beta within a couple of weeks, and the general release will probably be a couple of weeks after that, depending on how the beta goes, but usually it's about a couple of weeks. So in addition to the multi-year, which is the main focus of the talk, I do want to point out a few new user experience features that are going to be in both products: a welcome screen, a new results summary. I'll show these in a minute, and improvements to the time series viewer. But the new features that are just in HOMER Grid are dispatch log. I'm going to show all this, show that again in a minute. We have this enormous tariff database in HOMER Grid, and we're just adding more tariffs to it all the time, mostly in North America, so I apologize to people outside of North America. But the main new feature is this multi-year feature, and that's my main focus today. So to talk about some of the other new features, though, the goal of our goal now is to really improve the user experiences, and especially for new users. So a brand new user, when they first open HOMER, either HOMER, frankly, when the new HOMER Pro comes out, will get this welcome screen to show you some of the ways we think it helps to get started. So the setup assistant, we used to call that a wizard. It walks you through creating an initial HOMER file. It uses a lot of defaults, but the user puts in a few variables, and you end up with a real HOMER file you can open up in the main product and modify. The tour is also steps you through, but it's mostly just to show you where the features are, so you can do that very quickly. And the sample files are always a good way to get started. And if you look in the lower left, you can turn this off after you've seen it a few times. You probably don't need it once you're experienced. So that's the new welcome screen, and we hope that really helps people get started. We also have a new results summary. So it used to be when after HOMER finished calculating, it would jump you into a big table of numbers, the optimization results table, and that's still there up here on the upper right. But first, you're going to see a summary, and this is giving you summary information about the least cost system, and it's comparing it to what we call a base case or a status quo. It's comparing it to sort of doing nothing. In this case, it's adding a lot of PV and some batteries. It's got an excellent return on investment of over 50%. And if you look at the graph, you can see the blue line is the new system, and it's got, here's your capital costs, about $400,000, which is over here as well. But then much lower operating costs, which is the numbers are here, and you can see that after 2 years, it's paid itself back. And then down here it just says what's the total savings, and how does that break down between demand charge and energy charge. In this case, the demand charge is almost exactly 1/3 of this, and the savings then energy charge is 2/3. So that's so that helps. Just when you first get your results back, you have a summary of the least cost system. So another big change is the time series viewer, and there's quite a lot to show here. For those of you who've used HOMER in the past, this used to be just one big long list, and now we've got it categorized, which I think really helps. But more importantly, you can create your these preset graphs. So you set up a graph that you like, and you think, oh, I'm going to want to use this graph over and over again with other files. You can save it, and then it'll show up over here in this dropdown. HOMER will ship with several preset graphs already defined, and you can just add new ones to that. So everybody has their sort of favorite graph that they like. So that's one thing I want to show here. The other thing I want to show here is this dispatch log. So if you're in the time series viewer and you right click anywhere, this little pop-up comes up that lets you do several things. This has always been there, but we added this dispatch log choice, which if you choose that, then this window pops up which gives you some details about exactly how HOMER made its dispatch decisions in that period. So it's trying to shave your peak. Should it be charging batteries so it can discharge during a peak period in the future? It looks ahead to how it expects the energy prices to change, or so there's quite a bit of going on about this is the really difficult part of the whole solar plus storage and microgrid world, is trying to figure out when to charge and discharge the batteries. If you've got a backup generator, when to use that, etc. So this gives you information on how all that works, and you can, these arrows here let you toggle forward and backward in time, and there's another option I'll show later where you can get a text file of how, for the whole year, of how it made all those decisions. So one other thing to show here is that when you're doing multi-year, the time series viewer here shows a whole year's worth of simulation results, time step by time step. But if you're doing multi-year, up here you have to say, well, which year's simulation results do we want to see? So that's an important distinction. So let me talk a little bit more about multi-year analysis. It's as I think Marilyn mentioned, it's been an add-on or an upgrade in HOMER Pro now for almost 3 years, but we're just now adding it to HOMER Grid. And as it implies, and I think Marilyn mentioned, instead of just simulating 1 year and extrapolating the economics of how that system would operate for the project life, but not changing how it operates, this simulates every year of the project life. So when there are things that change over the life of the project, and now you can model how those changes happen. So in the past, we used to say, well, just do a sensitivity analysis, and you can see the impact of changes. But this is a much better way to see the impact of things that change over the course of the project life. And one caveat that I want to mention, because one of the things, and I'll show you the different things that can change, but one of the most important things that can change is load growth, or the load in general. And if it's changing in any substantial way, you probably want to break the full project life into shorter periods. That this is how you could model going back in and enhancing the system. So it used to be grant-funded projects would overbuild in the beginning, so they didn't have to go back later, which is difficult for a grant-funded project. But it's also not very cost-effective to overbuild initially. So now that the microgrid industry is becoming more of a commercial industry, you don't want to overbuild initially. And if you're treating these microgrids as a commercial venture, you're going to be in close contact with that community, with the system or the community or the facility anyway. And it's much more cost-effective to break it up into periods. And if you're expecting a significant load growth, go and enhance the system later. So instead of doing a 25-year project, you might want to break it into smaller projects and just see, to evaluate when it would make sense to go enhance it. So I just wanted to point that out. So what variables can have multi-year? So I've listed them over here. This is the load, and this happens to be a medical clinic in Bakersfield. You can see Bakersfield, California, excuse me. We have more than one load too. We have in HOMER Grid, we have a critical load and a non-critical load if you're modeling outages. In HOMER Pro, we also have 2 loads, so you can have them grow at different rates. If you have a backup generator, the fuel price can change. The utility rate, this happens to be I think that's a PG&E, time of use, no peak demand period. Anyway, if you think that's going to change what we're saying here at 2% a year, you can add that in. PV degradation, we've been asked for that a lot. I think the default is about 0.5% a year, depends on the technology. So you can model that. System fixed O&M costs is just like salaries or O&M costs that aren't impacted by the design of the system or the size of the system. So it's so you can escalate that. So the simplest thing to do is, as you can see here, put in 2% here or 5% a year increase here. But if you click this years button, first of all, you can see what 5% a year looks like over 15 years. But you can also come in here and modify that. So it doesn't have to be a constant escalation rate. You could say, oh, I don't expect the load to grow at all for the first 5 years, and then it's going to grow, or I know there's a big building project that's going to happen in year 3, or I already know what you can modify that in any way you want, basically. And the way you get into the multi-year is over here on the left. If you expand the project button, you get this additional choices, and the bottom one here is multi-year. So that's how you get to this screen. And okay, so that's on the input side. On the output side, after you've run it, now we're back here in the optimization table. This is the same. We've sort of pasted 2 different things on the same screen here. The upper part is what we've always had as an optimization results table, and you double click on this system design of your choice. The top one is the least cost system, and it pulls up the simulation results. So there's got 2 different screenshots here. The first screenshot I'm just showing that if you're looking at the simulation results, you have to tell Homer which year's simulation results you want to look at. So you do that with this little drop down in the upper left. And if you toggle through that, for example, on this electric tab, you can see that because the PV is degrading a little bit, or the load is growing, the utility, the brown section, would probably be increasing over time. In this case, it starts out in year 13, it's 22% of the load is met by the utility. The other thing I want to show is over here on the lower right. We've always had these time series plot and this other button, but now under other, we've added multi-year as a choice. And if you click on multi-year, it pulls up this next slide, which looks a little bit like the time series plot, but it's different because the x-axis is your years. So it's showing year 1, year 2, year 3, and the same thing. You hover over it, and you get, the date and the value of these 2 variables that we're plotting, which happen to be the AC primary load and the renewable fraction. And so you can see the load is growing, exponential growth. You can see the curve there a little bit, constant growth rate. And as the load grows, the renewable fraction is declining from its 75% in year 2, probably 76% in year 1. And by year 15, it's down to like 54% or so. And obviously, you can plot whatever you want. Now, as soon as you change anything here, the bottom, this part changes a little bit and gives you the opportunity to save that particular graph as one of your sort of custom presets, which will end up showing up over here. And you can make it a default if you want. So that's the multi-year results plot. And then I think I mentioned this already, but if you're looking at traditional time series plot, we've changed it a little bit. There's the, which I've already mentioned, and here's the drop down to tell Homer which year's data you want to look at. Now, another important topic that I haven't mentioned is battery degradation. So on the multi-year input, you could put in how quickly you think the batteries are going to degrade. On the multi-year input page, you can show how quickly you think PV is going to degrade. The battery degradation is a lot more complicated, frankly, because it's a function of how the battery gets used, which you don't know ahead of time, and also temperature is really important for battery degradation. So to model battery degradation, you need to be using the advanced storage module, which is an upgrade in Pro but standard in Grid. If you do that, you can see here, this screenshot happened to be taken from a model run where we did it for 10 years. And what we're showing here is that the load is constant, but the throughput is going down over time, and it's kind of accelerating. I guess year 7 starts to deteriorate a little faster. And as a result of the batteries losing capacity, the fuel consumption is going up. So this screenshot actually came from our HOMER Pro beta. or just no, HOMER Pro, right? Anyway, but battery degradation is a really important topic that people really care a lot about. Our new multi-year capability can handle that. It's a little bit different because you don't set a constant degradation rate. HOMER figures out the degradation based upon the parameters of the battery and how it's used during the simulation, and also temperature effects. So it's different, but it's also very important, and you can now do that. So to recap, our focus has been how do we improve the user experience, especially for new users, and adding this multi-year capability to HOMER Grid. And I talked also about the advanced storage module. And as Marilyn mentioned in the beginning, these are upgrades in HOMER Pro because we're trying to keep the base price of HOMER Pro inexpensive. So we have these upgrade modules, but it's standard in HOMER Grid. And just to reinforce what I just said, if you want to look at battery degradation, you have to be using the advanced storage module. So in our library of batteries, we have a whole library full of batteries. You have to look for the ones that say ASM. And if you want to create your own, it's best to copy an existing battery that has ASM in the name and modify the parameters as appropriate. And the final point that I always like to make is understanding the different ways that HOMER can be used. And I usually break both the project analysis but process, but also the whole project development process into sort of 3 stages. The first stage, I usually call it conceptual design. Some people call it pre-feasibility design. Is where you don't want to get real detailed. You want to do something relatively quick. You don't want to have to spend a lot of time and money on it. The goal of that is mostly to screen out projects that you don't want to look at and to have confidence that the project you are looking at is worth really devoting some serious resources into the design. And so I wouldn't use the multi-year capability during that initial conceptual design or pre-feasibility design. For that you want something that's really quick and easy. You probably want to use our optimizer algorithm instead of the search space. And you want to use our generic components and generic load profiles. But then if it looks promising, you want to devote some real resources to getting good load profiles. You want to talk to vendors about getting good quotes, and now you've got specific choices about component sizing, etc. So you use our search space, and that's when multi-year can be useful, is during that sort of more refined analysis. In truth, you have to use the search space if you're using multi-year because of some technical issues which I won't go into. But the other issue that's really important is, if you think about it, modeling simulating every time step for a project life of 20 years or whatever is going to take 20 times as long for the computer to come back with an answer. So that's another reason why I use multi-year later in the process when I want those greater details. There's a third stage of project development where you're actually going to create as-built engineering drawings. You're going to worry about things like what kind of wires to use, what kind of protection devices. There's all kinds of implementation details that HOMER doesn't get involved with. So it's sometimes useful to talk about what the model doesn't do, but HOMER's designed for that initial conceptual design or pre-feasibility analysis, and then this more refined design where multi-year becomes really useful, important. But there's a whole nother level of stage after that as well. So that's a recap, and I'll pass it off to Steffi now to take a look at questions that have come in, and happy to answer any questions.
Excellent. Well, thank you everyone for your time. We had some great questions come in. So a couple really good ones for Peter were, how is weather data handled in multi-year simulation? Can you do any kind of variability there?
So the short answer is no. We are talking to other data providers about making it easier to get multiple years of weather data. But at the moment, weather data is not part of MultiYear.
But you can do a sensitivity analysis on your solar or wind resource, of course.
Sure.
Question about, does MultiYear and HOMER grid, can you scale energy from demand separately?
The way HOMER handles load growth, it's similar to the way we handle sensitivities on load. It's a multiplier that multiplies the entire profile. So let's say you said 10%, and so in year 1 and year 2, let's say the load is 10% greater than year 1. That means the load in every time step, every hour, whatever your time steps are, is 10% higher than the previous year.
All right, thank you, Peter. In a multi-year model, can you change a rate schedule later in the project?
Well, you can model more than one utility rate, and you can compare them, and you can do the same thing that I suggested about breaking a long project into shorter periods, and it depends exactly what you're trying to do with that. I'm not sure what the questioner there was trying to accomplish, actually. So probably the best approach in a situation like that is to, if I understand the question correctly, is to break the project lifetime into multiple periods so that you can change the rate structure in a later period.
Kind of a general question, a summary question, kind of. What are the core differences between multi-year versus just a normal system analysis in HOMER?
So the core differences are, if you're worried about how this operation of the system is going to change, for example, if you're worried about PV degradation, or you're worried about battery degradation, or if you're worried about fuel prices, this allows you to see the impact on finances and of changes in things that will change. But it does give you a much more realistic projection of the performance of the system.
I'll take a shot at that question too, just from a really simplistic answer. If you're not using multi-year, HOMER will simulate 1 year and then use that 1 year to project out to the lifetime cost. So if you're using multi-year, it's going to explicitly model 25 years or however many years you set it up for.
Could you just explain again how you could break down a project into multi-year periods to test the effect of adding different generation kind of mid-projects and then combining them?
You know, I'd put that into kind of an advanced modeling. So this probably isn't for beginners really, but so let's say, okay, you think the load's going to grow at a relatively rapid rate, and certainly in the energy access market, that's a reasonable assumption. And then you're trying to figure out, well, when should I think about adding capacity? So let's say okay, instead of modeling it out for 20 years, let's model just the first 5 years, and let's design a system that will meet the load, including the load growth, but just for those 5 years. If you're expecting substantial load growth, let's say 10% a year, doesn't sound like a lot, but that means it's doubling every 7 years. That means in 21 years, it'll have gone up 8-fold. Well, it's not going to, well, first of all, that's a huge load growth. But secondly, even a more modest load growth, it's just much more economical to plan on going back, let's say in 5 years, and adding more solar, more batteries, whatever. So you set HOMER up for a 5-year run, tells you what's the least cost thing to do initially. Then you have to do a separate run where you treat the existing capacity as existing capacity, so you zero out its capital costs. You leave in replacement cost probably. And then you have HOMER optimize what's additional capacity that should be installed, either as a second PV array and then HOMER will find the least cost additions, given that you're assuming you're starting 5 years from now, and you can do that moving forward.
Okay, I think that we've answered quite a few of the questions. Let me take another look through. Does the multi-year feature, does the load growth say, will that affect the battery replacement? So does battery replacement depend on multi-year?
You know, that's a really good question. And actually, Steph, you might be better prepared to answer that question than I am. But HOMER will tell you when the battery's worn out. And if it's before the end of the project life, it will go ahead and replace the battery. And you'll incur the battery replacement cost because of the way we handle the economics of replacements. If you replace it near the end of the project life, we give you credit for not sort of using up the whole battery. And that the same is true in multi-year as in regular HOMER. In multi-year, we replace the battery. We show the batteries being replaced in the year that HOMER figures out that it needs replacement, right?
Right, and that's based on both the throughput or the shelf life, depending on which battery model you can use. There's different points at which it'll show that the battery needs to be replaced. So that's why we have a couple different battery models to capture different technology types, and also we have an idealized model, which is great for lithium ion, a kinetic model, which is great for lead acid, and our advanced storage module captures everything and is the most detailed of the models.
There are lots of questions here. There's almost too many to read. No, I think we've got the main ones. What I just wanted to say that I think we've got a lot of, well, some of the questions people have sent in are very specific to problems that you're having, and it's hard for us to answer those during a webinar because it might have to do with your system or something. So please contact usersupport.homerenergy.com. We have an excellent support team there. And, also, this is a pretty advanced group we have on here today. We had great questions, and some of you brought up things that are enhancements needed, and we really appreciate that. I also want to make sure everyone knows we recognize there's a lot to modeling with HOMER. There's times when letting us do the modeling for you can actually be the most economical solution. So whether you have a simple question or you just want to make sure your modeling is done right, get in touch with us and let us help you with that. So yeah, Peter, if you see another question on there, there was there was one I was thinking I wanted to address. Oh, it was, yeah, earlier on, someone asked very early on about some of the interface changes that we've made to HOMER Grid and about those in HOMER Pro. And yes, I do want to let everybody know that we are working on adding a lot of this functionality into HOMER Pro. We're working on a new release that is due out in beta, gosh, in a week or no, yeah, in like a week and a half. So, so watch for that. If you have a HOMER Pro license, you'll be contacted to participate in the beta. And then the general release is usually a couple weeks later.
Actually, we just had a conversation this morning about that. Well, so there's some of the stuff that I showed today is coming out in HOMER Pro right away. But I'm looking at one of the questions who I think they wanted us to redesign all of HOMER Pro to look like HOMER Grid. And literally, we did just have a conversation about that this morning. It's kind of a big project. And it was useful feedback to see that it sounds like somebody would like us to do that. It's not going to happen that more ambitious project. It's not going to happen in the next couple of weeks, but we have flagged it as something that we would like to do.
Great.
I interrupted you, Marilyn, but I do see a couple of questions here that I could answer.
Yeah, please.
One of them is really straightforward. Does the multi-year mode handle capacity fade for energy storage If yes, is it driven by time or discharge cycles? Yes, absolutely does. But as I said, you need to use the advanced storage module. You need to be using in HOMER one of the batteries that was created with the advanced storage module. And it is driven by both time and discharge cycles, and it incorporates the temperature effects as well, which are important. And then right below that is a question about dispatch strategies, which is probably a more an important question. So it is true in HOMER Pro we have multiple dispatch strategies, and we have APIs that let you create your own dispatch strategy in either MATLAB or C++. The reason, one of the main reasons that HOMER Grid is a separate product is because dispatching a grid-connected system with batteries and trying to do peak shaving, which is really important value proposition for a grid-connected battery behind the meter, is I don't know how many people on the call have given much thought to this. It's a very complicated problem because your demand charge is set by the peak 15-minute period in a whole month, which means you have to sort of think ahead for a whole month. It's a much more involved dispatch strategy. So in HOMER Grid, we do currently only have that one dispatch strategy. We've ported it over to HOMER Pro and called it predictive dispatch. So we have a new dispatch. We have a couple of new dispatch strategies. It's under controller in HOMER Pro, but HOMER Grid, it was quite a development for us. It's quite a complicated thing coming up with a good control strategy for grid-connected batteries. And it's something that the industry is really grappling with. And there's lots of people trying to do this with spreadsheets, et cetera, who are going to learn that that's not going to work very well. So take advantage of our learning there on that. So the short answer is no, we only have one dispatch strategy for HOMER Grid. The longer answer is there's a really good reason for that because of the complexity of coming up with a good control strategy when you're trying to do peak shaving. There's another question about documentation of our dispatch strategies, and there's a fair amount of documentation, and this new dispatch log capability that I demonstrated really can help you understand what HOMER is doing, what HOMER Grid is doing. So I encourage you to look at that.
Great. Okay. I think the timing's good. I just want to encourage you, again, appreciate everyone showing up today. And next month, our product management team, Steffi, and the associate product manager, Arabi Madhavan, will work together to show you how to really interpret and get the most out of your HOMER results. So we hope you'll sign up for that. And if you find these webinars useful, let us know and tell other people about them. If you didn't get your question answered, again, please send it to us either through your sales rep or our support desk. We absolutely, do want to help you understand how to use HOMER and understand how it can help you. We always record the webinars. You will get an email in a few days with the recording, and we hope to see you again next month. Thank you.